Hello and welcome to the 15th lecture on coordination chemistry. Yesterday we had a rapid round discussion on stability of complexes without writing any notes. Also we revised the CFT for a few compounds, including the color properties. Most of the time we spent on CTS, as if CTS is our most favorite subject. We are joined by Satyajit. Also, today we will be again revising. Supposing I'll say CsCOCl4 2 minus, if the VBT pattern diagram and magnetic properties, I cannot ask you to explain the color properties in VBT, only magnetic properties. And also tell me the same, whether TD or SP. हाँ हाँ कहेंगी କିଏ କିଏ ନା ନା ମୁଁ ଆଣିପାରିବିନି କ୍ଲାସ୍ ଆରମ୍ଭ ହେଇଗଲାଣି ହେଲା ଥ୍ୟାଙ୍କ ୟୁ ତାକୁ ଛାଡ଼ିବାକୁ ଯିବି ଆଣିବାକୁ ଯିବି ମୋର ଧନ୍ଦା ନାହିଁ oh I'm so sorry this is in record this is about my most favorite granddaughter here Zia. He wants me to drop every day and to pick. I had to take a recourse to blatant lies. In the morning, I said I have a class. By that time, I had no class. I had to, otherwise, no way out. Sometimes falsehood, lies will help you. We are joined by. No, no. Okay. So tell me, what is the shape of tetrachloride of cobaltate 2?
Tetrahedral.
Definitely, because 3D and this is a weak field ligand, and hence it is tetrahedral in shape. Yes, any question, Chris? And this is
No, sir.
cobalt 2 plus, so it is D7 configuration. So here we have to show the hybridization only. This is 3D, 4s, 4p, and there are 5 orbitals. Since it will be a high spin complex, no rearrangement of d electrons, hund, then poly, and we have sp3 hybridization here for explaining the tetrahedral geometry. These are the ligands electrons in the sp3 hybrid orbitals, and the number of unpaired electrons remain the same. 3, no change. And yes, we have done it. We can't talk about it. Had it been CFT, which we also didn't do, it is T2G, I think we did, no. T2Z, sorry, EZ is down, T2Z is up, and this del T is very small, so therefore it will form a high spin complex, same, hund, poly. So same 3 unpaired electrons. But we can think of a good, not very intense, but moderately intense color, because this can go without change of spin to pair, and it is as a tetrahedral geometry, the Lapote selection rule is partially followed, as well as spin selection rule is followed, del S is equal to 0. So It gives a moderately intense spectra color. And if you are given the lambda max value for absorption, you can find out what color it is absorbing, and then look to the complementary color in the color wheel. You can find out what is its exhibiting color. Okay. Now you tell me, I am in a mood to complete. If we convince ourselves that all the 9 points that we had discussed on stability of complexes, you will write them at home, and you can understand, because it's not too late. The only interesting point is Irving William order for M2 plus 3D metal ion divalent 2 plus octahedral high spin complex with aqua ligands mostly. How the humps occurs in a different position than expected. One hump chromium 2 plus, the other hump, big hump at copper 2 plus, because they show a large distortion in the octahedral geometry. Will you write down at home the collect effect and everything, all the 9 points? Can you write down at home? Then only we will be in a position to finish today. Or else we shall write a brief note on every point. What do you want? Please tell me honestly. RS.
Sir, we will write.
Chris. Chris.
Yes, sir.
What do you want? Indecisive. Indecisive. He I know him very much, as he knows me also very much, that he will not like to leave anything. He is prepared to spend any time with the teacher, extra time with the teacher, but he doesn't like to leave anything. If by writing something, some better, understanding, grasping will happen, then why not? Okay. Mm, factors affecting thermodynamic stability. Just we shall be writing of complexes.
ऐसे একটা জি है बोले ना टी2 জি या वीजी
Oh, so sorry. Thank you. Thank you. Only and thank you. But I had
यस
made a
sir.
change to this one. Thank you, thank you. I have a decaf hasiwala. Yeah. First factor, let me write down from my memory. Factor is charge, and I'm talking about thermodynamic stability, which is the stability. Stability means thermodynamic stability, information constant. And first, let us write down the points. Then we shall see how the stepwise formation constants multiplied together will give you the overall formation constant. That also I'll write down. I forgot. Charge and size of metal ion. So stability is directly proportional to magnitude of charge and inversely proportional to size. Less is the size, more is the charge, more is the polarizing power. So that I can give you an example. Ferricyanide complex is more stable than ferrocyanide complex. As far as the stability goes, the formation constant goes. This is plus 2, this is plus 3. So also the magnesium complex is less stable than beryllium complex. That example also I gave you. So in this particular point, we talked about Irving William natural R series. This is for the OH complex M2 plus 3D OH HS complex, high spin complex with aqua ligands. What is the order? Can you tell me? Scandium doesn't have a 2 plus. So titanium 2 plus
less than
less than
vanadium, vanadium,
yes.
less than chromium, greater than titanium, manganese.
Yes. Chromium sits on the, because of the distortion. Today I will discuss about that. The Jahn-Taylor distortion. Instead of vanadium sitting, D3 configuration is sitting, is, down the series, across the series size decreases. The pattern is the increasing stability. But this is complicated, marred by the CFAC effect as well as the ZTD effect, right? So this is ZTD effect. Today we shall giant Taylor distortion effect, and this is CFAC 0 effect, and then it goes on again increasing. Then tell me, manganese, then
Iron,
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 then
cobalt,
cobalt, nickel,
then nickel,
copper, zinc.
copper, then what?
Greater than zinc.
Greater than zinc. Even zinc is greater than nickel. So the peak point comes here and here, most stable. Strong ZTD. And if you remember the peak like this, starting from, this is the CF, the stability constant. This is the KF of M2 plus. This is, supposing this is uh, titanium 2 plus, then vanadium, then chromium sits on a hump, then manganese is way below. The increase has been very. Then copper sits here, then zinc. Zinc is less stable. Oh, I wrote something different. Yeah, but I have not written. So zinc comes down. This is zinc. This is copper 2 plus. So I can show you, this is the atomic number as this, you know. Yes, this one. Zinc is below nickel. Zinc is below nickel. This is atomic number, and this is log of formation constant, log of Kf. Doesn't matter. Atomic number. This is log Kf. So the stability is maximum for A, and the zinc is just below, less than nickel. And next point is a cold drink. Cold drink वाला आजिकल आसुनी मते कहता ଆପଣ ତ ପିଇଲେଣି ଆକ୍ଚୁଆଲି ମୁଁ କୋଲ୍ଡ ସେଟା ନଥିଲା ଆଜିକାଲି କୋଲ୍ଡ ଡ୍ରିଙ୍କ ଆମେ ସବୁ ବାହାରେ ରଖୁଛୁ ଭିତରେ କିଛି ନାହିଁ ଏଭ୍ରିଥିଙ୍ଗ ହଟ୍ ବହୁତ ଶୀତ ପଡୁଛି ଦେନ୍ 3 ନମ୍ବର ପଏଣ୍ଟ କ'ଣ ଥିଲା କିଏ କହିପାରିବ
The 3D, 4D, 5D ion.
हाँ नेचर ऑफ मैटर है 3D is less stable than 4D, less stable than 5D. Then base strength. Cyanide is a stronger base than ammonia, is stronger base than water. So a particular ligand remaining fixed, say cobalt. And coordination number fixed. You can make it 6 also. Two plus. This is 4 minus. If you make it cyanide complex, it will be 4 minus. This is 2 plus and this is 2 plus. Next point, HSAB, hard and soft acid base theory. Hard acids, the metal ions, Lewis acids. Small size metal ions of 3D series, mostly, and high oxidation state. So that size will be automatically less. Chromium 3 plus, chromium 6 plus, etc. 3D. Manganese 4 plus, 6 plus. These are hard acids. Soft acids, metals are acids acting as Lewis acids. But soft metal ions, large size, like silver plus, like platinum 4 plus, platinum 2 plus, 4 plus then you have AU plus, they are soft, large size, high polarizability, and empty hard Lewis bases, ligands, small size. Like fluoride, chlorides, water, ammonia, etc. Small size, they are hard bases. Soft bases, they are large size. Like PH3, like iodide, bromide, etc. अब HSA भी theory कहूँ hard acid can form stable complex with hard base. Acid is metal, base is ligand. Soft acid will form stable complex with soft base. Stable. The opposite.
सर टिके ऊपर का देखिए सर कहाँ ऊपर का?
Tapurgu. Tapurgu.
नो सर नो
So hard, soft combination is unstable. Example कौन नहीं थे ना आमे जदि फ्लोराइड कॉम्प्लेक्स करिबा सेटा निकेल संगरे फ्लोराइड complex is more stable than palladium संगरे फ्लोराइड complex कि platinum संगरे. On the other hand, iodide complex पाई platinum संगरे it is soft is more stable than platinum with fluoride or fluoride. Size बढ़िला माने तो polarizability बढ़िबो, softness बढ़िबो, एड मेटल साइज सब साइज डिपेंडेंट. साइज कमिले सॉफ्टनेस कमिबो, हार्डनेस बढ़िबो, साइज बढ़िले हार्डनेस कमिबो, सॉफ्टनेस बढ़िबो. सो एमती गुडे एग्जांपल दि तीनटा एग्जांपल देइछि तमे सब कॉपी करिवो. दिस इज ए soft metal ion, this is a hard ligand, so it is less stable than this is hard, this is hard, this is soft, this is soft, so it forms a 4 टा लिखे को भूल जाइए, it is I4, it is F4, but this is soft, this is hard, so such combination produce a less stable or unstable complex. आउ कौन पढ़ी थिले केते नंबर पॉइंट गलानी एचएसएबी थ्योरी टा हला 5 नंबर 6 नंबर कौन जहाँ मन पड़ुछि लिखि जाओ पिलेट इफेक्ट. Five-membered ring is more stable than six-membered ring due to increase in entropy or entropy driven. Supposing cobalt aku 6टा ammonia दबा to produce hexamine, एपटे 7टा को सेपटे 7टा मॉलिक्यूल किंतु को से 3टा इथिलीन डायमीन दबा से एका कोऑर्डिनेशन नंबर पाइबा एका डोनर से नाइट्रोजन किंतु स्टेबिलिटी बहुत अधिका एपटे 4टा मॉलिक्यूल एपटे 7टा मॉलिक्यूल, so increase in entropy. So EDTA complex आउरी EDTA complex गोटे लोक 4 माइनस से गोटे लोक हेले तार काम हो जीवो so इथरे मध्य सेया in both the cases. So more is the entropy increase, more is the less is delta G is more negative, so formation constant will be more. So this is all entropy driven. And गोटे हला other effects, other factors हला for select effect, number of rings. Greater the number, stability is proportional to number of rings. So for example, say cobalt En whole 3 is less stable than cobalt di-En whole 2. Coordination number 6. But एथरे 3टा रिंग एथरे 4टा रिंग करिके देखिबो गोटे डाई-En 2टा रिंग प्रोड्यूस करिवो गोटे En गोटे रिंग प्रोड्यूस करिवो ऑल 5 मेंबर रिंग नंबर ऑफ रिंग्स ଆଉ ଗୋଟେ କଣ ଥିଲା ଆଉ ଗୋଟେ କଣ पॉइंट थिला ए किलेट इफेक्ट ପାଇଁ इंडिविजुअल रिंग साइज तो 5 मेंबर रिंग लिखि देली से तो समस्त ଆଉ ଗୋଟେ ହେଲା ଏ କଥା ଗୁଡାକ this is recorded कौन कर देली number of rings size of the ring तो already we have done so that these are the 2 points then macrocyclic effect already discussed तो लिखि दउची size of the ring 5 and 6 stable out of which 5 member is more stable so cobalt En whole 3 is more stable than En whole 3 Tn is trimethylene diamine it will form a 6 member ring okay then asla macrocyclic effect 7 it needs macrocyclic ligands like crown ethers cyclams ओ जगह NH थिले त कोन cyclams orphins it is very highly stable even more the effect is more pronounced than skillet effect due to both entropy delta S positive and enthalpy delta S more negative so it is driven both by entropy and enthalpy example chlorophyll which already हम परिचय ये then hemoglobin these are extremely stable complexes because the size of the cavity of the ligands the macrocyclic ligands fits or matches with the size of the metal ion that is the important factor fits or matches with the size of the metal ion सेथिପାଇଁ stability 4 लग जाए okay what other effect we missed out what other effect लिख लो did you write
Yes, sir.
and the steric effect and surrounding conditions these are unimportant things and just we have written base strength we have written strength of the ligand oh that is the spectrochemical series of the ligands stability of the metal ion that we have written yes done one point we will add that is the what 7 8 strength of the metal ion sorry ligands a spectrochemical series For example, Cn minus is a stronger ligand than ammonia. Ammonia is stronger ligand than water, stronger ligand than, say, chloride. Then if you take all same, say iron 6, 2 plus the above, so 4 minus is more stable than 2 plus, more stable than. এটা base strength অনুସାরে ବି ବୁଝେଇ ପାରିବା, particularly এই ଜିନିଷଟା, but ସେଇଟା ଗୋଟେ factor। କିଏ ଗୋଟେ ଖୁ ଖୁ ହଉଛି, ଶୁ ଶୁ କିଏ ହଉଛି। ଅବଶ୍ୟ FeCl6 4 minus is less stable than FeF6 6 minus, because chloride ion, although taken as a hard base, but still size is greater. Softness is more in case of chloride ion compared to fluoride ion. So compared to hexafluoridoferrate, hexachloridoferrate is less stable. But I have not brought fluorido in our competition. So that is the end of our writing. Today I shall be explaining to you so many things. We'll first talk about metal carbonyls, and complexes with haptic bonds I have already introduced, Jahn-Taylor effect, and strength of hydrated and structure of hydrated crystals. Now, I will give you the notes I have written in my hand, but we will be writing also today that metal carbonyls have a very peculiar, unique property of satisfying 18 electron rule, the total number of valence electrons, including the ligands, 12 electrons from the ligands, they satisfy 18 electron. Number of electrons lost, we subtracted, number of electrons gained to be added. And whatever electrons are there in the NS and the valence means NS and remain. For example, we apply to, the exception is hexacarbonyl vanadium 0. There's an exception. It has 17 electrons. This is the only exception that has been noticed. But most of the cases, 18 electron rule. For example, nickel tetracarbonyl. Nickel is 0, so it is 3d8 or S2 plus 4 plus 4 to the 8. So you have in the D, these are the valence electrons, 8 plus 2, 10, plus 8 from 4 donors, 4 ligands, so 18. So the general, there will be a general formula for it. The general formula for all mononuclear carbonyls where there is only one metal, it has to be CO to the CO whole n. And what is n? N is nothing but half of the difference in electron number between metal atom, neutral metal atom, and the nearest noble gas. That means 2n is equal to the difference in electron number between the neutral metal atom and the nearest noble gas. For example, nickel, the atomic number is 28. Difference is always positive. So the nearest noble gas is krypton, 36. So 36 minus 28 is 8. 8 is 2n. So divided by 2, n is equal to 4. So nickel cannot form CO whole 5 or CO whole 3 or whole 6. It has to form CO whole 4. Iron will definitely form CO whole 5. See, iron, the atomic number is 26, so electron number is 26, all. And the nearest noble gas is same krypton, 36 minus 26, 10. 10 divided by 2 is 5. So, and chromium cannot form CrCO whole 5 or 4. It has to form 6 because chromium is 24, 36 minus 24, 12, 12 by 2 is 6. So this is the rule where 2n is the difference between the atomic number of the nearest noble gas and the atomic number of the neutral atom. I'll tell you. Now just see, binuclear, where there are two metal atoms, and it is a binuclear complex. Just like we have bridging ligands, mu amido, this will be mu carbonyl. If there will be a bridging ligand, then there will be mu term will come in between. So the formula is different. M2 CO2n minus 1. 2n, the definition holds good, same. The difference between the atomic number of the nearest noble gas and the atomic number of the neutral atom. So here the formula is 2n minus 1. Cobalt, if there are two cobalt atoms, it will take 8 carbon monoxide. Why? Because see, this, if we equalize 2n minus 1 is equal to 8. Supposing we start and find the value of n. So n, say 2n minus 1 is equal to 8. So then 2n is equal to how much? 9. So is it the difference between, cobalt is 27 minus 36. So it's 9. Therefore, dicobalt will form definitely octacarbonyl. Iron will form nonacarbonyl because if 2n minus 1 is equal to 9, then 2n is equal to 10. So that 36 minus 26 is equal to 10. So these are very, and trinuclear will have a different formula. M3 CO 3n minus 3. So where same 2n is same. So iron, if there are 3 iron atoms, there has to be 12 carbon monoxide. If 12 is equal to 3n minus 3, let us find out what is 2n. So 3n is equal to 15, n is equal to 5, 2n is equal to 10. So 2n, so we have already seen an iron 36 minus 26 is equal to 10. So if there are 3 iron trinuclear carbonyl complex, then it has to take 12. That is the rule. Then only it will also obey the 18 electron rule. Tetranuclear, the formula is different. M4 4n minus 6. Cobalt, if there are 4 cobalt atoms, all are 0 state, there will be 12. Because if 4n minus 6 is equal to 12, then 4n is equal to 18, 2n is equal to 9. So that is difference between 36 minus 27, that is 9. So the bonding, as I have already told you, I shall explain in simple VBT MOT combined, not the ligand field theory, which I have not yet introduced. You know, these are pi electron, pi acceptor ligands. Sigma donor, everyone is a sigma donor. That's common to all types of ligands. But this is pi acceptor. Its antibonding orbital, pi star, is ready to accept a sidewise overlapping. So the metal uses its T2Z electron to sidewise overlap with a vacant orbital for pi bonding, and sigma bonding is used by the ligand sigma orbital uh, to form the sigma bond. And in ligand field theory will known in different way, but I'm not explaining in the form of ligand field theory. So here, just applying the VBT and a little bit of MOT, I mean molecular MOT, carbon monoxide. I'm saying pi star that belong to, we have studied the MOT of carbon monoxide, where a very peculiar kind of differences. Oxygen is below, carbon is up. But whatever may be the case, the pi bonding MOs, pi 2px, pi TPy comes lower, and sigma 2pz comes above, and that is closer to carbon, as I have already told you, and that is the HOMO. Highest occupied molecular orbital is sigma 2pz. So that will donate uh, the pair to a vacant, or if you apply VBT, simple VBT, this is MOT. Simple VBT, carbon is sp hybridized, so one of the sp hybrid orbitals carrying a lone pair, it will overlap with a vacant d orbital, say dxy or dyz, say for example dyz, which is vacant, which will be overlapping directly, not laterally, but coaxially, directly to form sigma bond. And the pi bond is the back bonding, d pi p pi back bonding, which you already know, I have explained. So this is the back bonding, this field orbital of T2Z, that with the vacant pi star orbital of carbon monoxide हो, या नाइट्राइट हो, एन हो, या थायोसाइनाइटो हो, और कार्बोनिल हो, जो भी हो, साइनाइडो हो, इसमें भी पाई स्टार होता है, सो खाली होता है, सो वी हैव ए pi bond. And this is favored by lower oxidation state. Zero state favors the bonding. Even negative state has a stronger bonding than zero state. So less is the oxidation state, greater is the stability, because more number of electrons will try to form the pi bond. As I have already explained, the pi bonding will be stronger. And therefore, I have given an example where this nickel is in the zero state, here cobalt is in the -1 state. So the coordination number is 4, all are tetrahedral complexes, but here iron is in the -2 state. So extra 2 electrons have been fed. Carbon monoxide is neutral. So you find the stability of this is greatest, followed by this, followed by this. And as the pi bond character becomes more, then the metal carbon bond length becomes shorter than the metal carbon bond in pure alkyl ligand. CH3 minus can be also a ligand. That is a pure MC sigma bond. There is no question of any pi bond there, as we shall see. So such cases, the bond length is greater because there is no pi bonding, there is no d pi p pi back bonding. So it's longer bond, but this is carbonyl complexes have MC bond which is shorter than normal MC sigma bonds. I have written whatever maximum required the notes. You have to only write down at your home. And on the other hand, the CO triple bond O acquires a partial, you know, I mean the bond order decreases because the flow of electron from the metal ion to the vacant orbital, pi star orbital, make the one of the pi bond gets polarized, so that the bond order becomes less than 3. So carbon monoxide bond length, whatever is the bond length in pure carbon monoxide, that will be lengthened. That length will be more. As the bond order decreases, bond length increases. So that we have already discussed before, and I have written that. Now I have shown some of the structures. Sometimes it appears in IIT Advanced, not in NEET. So dicobalt, octa carbonyl dicobalt is not that. The actual name will be a dimu carbonyl, because there are two carbonyl bridging ligands, and 3 on each side. There is a metal bond also, and there is another isomer where there is only metal bond, there is no bridging ligand. 4 are attached to each cobalt, but this M2CO10 all have identical, having metal bond. Manganese, its brother is technetium, is dead fellow, and rhenium. So all these have similar, no bridging carbonyl, 5 on each manganese. And this Fe2CO9 will have three bridging carbonyl groups and three on each side. And Fe3CO12 has two bridging carbonyls between the two iron atoms, which have been also directly bonded and which have been bonded with the three carbonyls on the outer side. But the other one, which has no bridging, which has only there is a metal carbonyl, but there is no bridging carbonyl, that is bonded with 4 carbon monoxide. But that is not the case with CO4, CO12. In this is CO4, CO12. You find there is a tetrahedron where the corners are occupied by the cobalt atoms. The corners of the tetrahedron are occupied by cobalt atoms. And one carbon is joined with 3 carbonyl ligands, carbon monoxide ligands on the other side, which is directly bonded to uh, diagonally uh, occupying cobalt. But this too has no bridging ligands. But those which have connected with 2 carbon monoxides, they have bridging ligands between this, between this, between this, between this, between this, between this. But 3 and others, they are bonded to each other. Each cobalt is bonded to 3 other cobalts. This cobalt, this cobalt, this. That is there. But there is no bridging carbonyl, both cobalt and rhodium. But iridium has different one. So, and we have also seen that, let us write down, what is the time now? I think he must be gone. Yeah, must be gone. I think we stop it here. No, it's another 10 minutes is okay? Or stop it
Yes,
here, or
sir.
write down. What is, so tomorrow is today is your Thursday. So tomorrow, Friday, will be ending up, and today will be 31st. Today is your 31st, right? Tomorrow will be 1st. Okay. 1st of November, we will finish the remaining portion, including JTD and MOT also, LFT. Right? So let us write down, instead of going to the other aspects like metallocene and haptic bonds, which are important, Zeiss salt and ferrocene. So let us write a few words on carbonyl, metal carbonyls. What we know, they're mostly colorless. Some of them are yellow in color. We know the reason. So the general formula, who tell me? So mononuclear, what is the general formula? 18 electron rule is obeyed. Exception হচ্ছে vanadium hexacarbonyl. What is the general formula for mononuclear metal carbonyls? MCO whole, how much? ଏତିକି ତମର ମେମୋରି ଯଦି ରହୁନି, ତମେ କାହିଁକି ତାହେଲେ ତମେ କେମିତି ମେଡିକାଲ ପଢିବ? What? N, ଖାଲି N, ଖାଲି N. Where ଏଇଠୁ ଆରମ୍ଭ ହେଲା. What is N? Na 2N is the difference in atomic number. Let me change number of nearest noble gas and a neutral atom, a transition metal atom. So nickel can form tetracarbonyl. I'm showing you one. Nickel is 28 and the nearest inert gas is krypton and it is 8, and that if that is equal to 2n, then n is equal to 4. So it has to be 4. Similarly, iron has to be pentacarbonyl. Sorry, because uh, the difference, this is 26, 36 is 10. So if this is equal to 2n, so n is equal to 5. So also chromium should be hexa. You will do it. And then binuclear, what is the formula? M2 CO whole 2n minus 1, right?
Yes, sir.
Yes. So 2n is definition is same. So cobalt can have 8 carbon monoxide. So that 8 is equal to 2n minus 1, then 2n is equal to 9. So 9 is nothing but 36 minus 27 cobalt, that is equal to 9. Similarly, iron will have 9, cannot have 8. Nonna carbonyl, di iron. Now you have to see if there is a bridging ligand, the name will be different with mu carbonyl. So this you can justify. Similarly, trinuclear, what is the formula? M3 CO 3n minus 3. So Fe3 will pick up 12 carbon monoxide. So if 12 is equal to 3n minus 3, then 2n is equal to how much? 10. So n 2n, that is 36 minus 26 iron is equal to 10. And so on. Just draw tetranuclear. What is the formula? Sometimes, because I was long ago, maybe 10 years before, I was not talking about metal carbonyls much. Because in some IIT advanced, you know, even the bonding, how many bridging oxygen they came, I was really surprised why the students should memorize. So this has to, I mean, that compelled me to put the details of metal carbonyls as much as possible for you. And this is formula is M4 CO 4n minus 6. And the example is cobalt, again 4, again 12. Iron 3 was 12, but cobalt 4 is 12. You can justify that. Bonding, this is the metal, 0 state, sigma bonding with carbon monoxide, sigma. Either we say sp hybrid orbital or MOT, this is sigma 2pz, the MOT, and this is a vacant d orbital. Supposing that should be directly, the picture is little, it should be directly bonded. So the d orbital is vacant d orbital of the metal, sigma. But pi will be opposite. Will be, I'm doing, supposing this is 3dyz, this is field, And this is the antibonding orbital, plus minus minus plus. So this is pi star. So there is a sidewise overlapping between this vacant field, blue. This is pi. So pi is this. Pi bonding is p pi d pi back bonding. So metal carbonyl, and there will be partial polarization of a pi bond. So ultimately, this will have a, I'm only drawing one carbonyl. So MC bond length decreased and C triple bond length increased in the complex. That's it. So we close today and we will have a finishing line tomorrow. Is it okay? Tomorrow you are available? Kamalan, Krishna, Haris? Hmm? Tomorrow we have, I don't know, is Halloween. Tomorrow we have, they have bought some scary masks for us. Everyone with scary masks and many other costumes. They will be going to different places, making fun and collect. And kids will collect so many candies. It's a great festival here. So, but finger crossed. I'm a Kori Pariva because I am ready. I prepared the slides and everything is ready. So I, you're ready though. Are ready ki naam?
Yes, sir.
Yes, sir.
Okay. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.